Good morning. Today, let us study about some concepts and some new items. First, let us discuss about a random variable. What is a random variable? Random variable means a variable which takes value or whose values correspond to the values of a or the outcomes of a random experiment is termed as a random variable. Random variable means a variable whose values correspond to the results or the outcomes of a random experiment. For example, tossing two coins, that is a random experiment. That is, its um, results completely depends upon chance. So when we toss two coins, we will have the following results. What are the results? We will be getting T means when two coins are being tossed, we will get two tails, or we will get the first one head and the second one tail, or the first one tail and the second one head, or both may be head. So these are the four results when we toss two coins. Okay, therefore, suppose the variable represents number of heads. In that case, zero heads. Zero heads means one result is there. One head, there are two results, and two heads, one result. Therefore, let x be a random variable which takes values 0, 1 and 2. This variable x may be called a random variable because its values correspond to the results of a random experiment. Okay. Random variable may be discrete or continuous. Discrete random variable means the variable takes only specific value or integral values. Okay. But in the case of continuous random variables, those variables takes value in between a specific interval. Okay. They are termed as continuous random variables. Next, let us discuss about probability distribution, also known as probability density function or probability function. Okay, and let x be a random variable and it takes values x1, x2, x3, etc. And let this small letter x be any value which represent these values, so that the probability that x takes the value x is termed as probability function or probability density function, denoted by f of x or p of x. That means x is a random variable which may take any of these values, and a general representative x. X represents all these. And what is the probability that x takes the value x is termed as probability function or density function, or represented as f of x or p of x. And p of x is equal to, therefore, p of x takes the value x. Okay, when x takes value x1, we are having corresponding probability p of x1. When x takes the value x2, we are having corresponding probability p of x2. And also p of x1 plus p of x2 plus etc. is equal to 1. Also, P of x greater than or equal to 0. Okay. For example, when we toss two coins, the random variable which represents getting heads may take values 0, 1 and 2. Therefore, probability that the random variable takes the value 0 is equal to 1 by 4. There will be 4 outcomes. So, getting 0 heads will be only 1. So, 1 by 4. So, probability that x takes the value 1 is equal to 2 by 4. And probability that x takes the value 2 represent 1 by 4. So if we represent this in the form of a probability distribution, x takes the value 0, 1 and 2. P of x represents 0 heads means 1 by 4 is the probability. 1 head means 2 by 4 is the probability. And 2 is 1 by 4 is the probability. This is the probability distribution. Probability distribution possesses two properties. The first property is that P of x1 plus P of x2 plus etc. is equal to 1. That is the first probability. Sum of the probabilities will be 1. And the second property is that all the probabilities will be greater than or equal to 0. These are the two properties of a probability distribution. Okay. Next is expectation of x. Let x be a random variable which takes values x1, x2, x3, etc. with corresponding probabilities P of x1, P of x2, etc. Then expectation of x means expectation of x. We write expectation of x like this, means x1 into P of x1, that is x1 is the value of the variable and multiplied by the corresponding probability plus x2 into P of x2 plus etc. That is sigma x P of x. This is what is known as expectation of x. For example, when we throw a die, the variable x may take values 1, 2, 3, 4, 5, 6. There are 6 spaces in the case of a die. And they are all are having probabilities 1 by 6. 1 by 6 is the probability of getting all these numbers. Then, what is the expected value of the variable x? Here x takes the value 1, 2, 3, 4, 5, 6. What is the expected value of x? Is equal to 1 into 1 by 6 plus 1 into 1 by 6 plus 2 into 1 by 6 plus 3 into 1 by 6 plus 4 into 1 by 6 plus 5 into 1 by 6 plus 6 into 1 by 6. So, the answer will be 21 by 6. That is the expected value of x.